Natural gas has enormous potential as a versatile energy source. While it's had a history of powering electric generators and heating stovetops, it's growing in use as an efficient fuel that also powers cars and trucks. But what exactly is natural gas? Natural gas is a naturally occurring chemical, primarily made up of methane, CH4. Its purity makes it an environmentally friendly fuel. Methane does not leave a residue when burned, so its emissions do not react with sunlight to create smog. The natural gas we use today began as microscopic plants and animals living in the ocean tens of millions of years ago. As they thrived, they absorbed energy from the sun, which was stored as carbon molecules in their bodies. When they died, they sank to the bottom of the sea and were covered by layer after layer of sediment. As these plants and animals became buried deeper in the earth over millions of years, heat and pressure began to rise. The amount of pressure and degree of heat transformed the biomatter into natural gas. After natural gas was formed, it tended to migrate upward through tiny pores and cracks in the surrounding rock. Some natural gas seeped to the surface, while other deposits traveled upward until they were trapped under impermeable layers of rock, such as shale or clay. These trapped deposits are where we find natural gas today. In 1859, Edwin Drake drilled the first commercial well in Titusville, Pennsylvania, striking natural gas and oil. This is considered by many to be the beginning of the natural gas industry. For most of the 1800s, natural gas was used almost exclusively as a fuel for lamps. Because no pipeline network existed to transport large amounts of gas over long distances, most of the gas was used to light local city streets. It was moved through small-bore lead pipe. Then, in 1885, Robert Bunsen invented a burner that mixed air with natural gas. The Bunsen burner showed how gas could provide heat for cooking and warming buildings. After the 1890s, many cities began converting their street lamps to electricity, forcing gas producers to look for new markets. But the lack of mobility to transport gas to consumers was still an issue. In the energy industry, natural gas was originally obtained as a byproduct from oil production. Since it was viewed as too costly to produce, much of it was burned off by flaring at the wellhead. Improvements in metals, welding techniques, and pipe making during World War II opened natural gas to new markets thanks to pipeline networks. Throughout the 1950s and 1960s, thousands of miles of pipeline were constructed throughout the United States. Although natural gas was becoming economically attractive with a growing pipeline network, crude oil was still far more popular and more widely used as a source of energy. For years, the industry perception remained that supplies of natural gas were limited. Although natural gas had been discovered in tight rock formations called shale, it was deemed too expensive and difficult to harness. With advances in drilling technology, new solutions emerged that solved these issues. Horizontal drilling and hydraulic fracturing, commonly referred to as fracking, were introduced as innovative techniques to reach shale deposits and harvest natural gas. Originally pioneered in the 1940s and refined in the 1970s, these processes have revolutionized the industry.
After the well site has been carefully prepared to meet environmental, health, and safety standards, drilling can begin. This is an intricate operation requiring a well-planned infrastructure. A variety of processes and expert, well-trained specialists are used to bring natural gas to the surface. Chesapeake works with these experts during every aspect of the project, while strictly adhering to all individual state regulations. During the drilling process, the rig is in constant operation 24 hours a day, 7 days a week, for approximately 21 to 28 days. As an added precaution in some areas, a protective mat covers 2/3 of the pad site. Utilizing heavy-duty industrial-strength drill bits, a typical well is drilled in several stages, starting with a large diameter drill bit and then successively smaller drill bits as the drilling is advanced. After drilling each portion of the well, nested steel protective casing is cemented into place. This will protect groundwater and maintain the integrity of the well. Initially, and prior to moving in the drilling rig, a large diameter hole is drilled for the first 50 to 80 feet. Conductor casing is then cemented into place, stabilizing the ground around the drilling rig and wellhead and isolating the well from most private water wells. In the Marcellus area, the freshwater zone extends to approximately 800 feet below ground. The freshwater zone consists of porous sandstone and rock stratas containing water within the pore space of the rock. Chesapeake utilizes air drilling until the hole is advanced to an average of 100 to 200 feet below the base of the freshwater zone. This provides added protection to the freshwater zone. A series of compressors and boosters generate the air that is used to lift the rock cuttings and fresh water into steel bins. The rock cuttings are then disposed of within state guidelines and permits. The drilling equipment is retracted to the surface and stored for the second stage of drilling. To protect the integrity of the hole and to protect the surrounding deep freshwater zone, a second layer of steel casing, called surface casing, is installed and cemented inside the newly drilled hole and conductor casing. Cement is pumped down through the surface casing and up along the sides of the well to provide a proper seal. This completely isolates the well from the deepest of private or municipal water wells. A blowout preventer is installed after the surface casing has been cemented. The blowout preventer is a series of high-pressure safety valves and seals attached to the top of the casing to control well pressure and prevent surface releases. Next, a small drilling assembly is passed down through the surface casing. At the bottom of the casing, the bit drills through the float equipment and cement, continuing its journey to the natural gas target area as deep as 8,000 feet below the surface. The drilling method employed below the surface casing uses drilling mud, which is a non-hazardous mixture based on bentonite clay or synthetic thickeners. In addition to lifting the rock cuttings out of the hole, drilling mud also helps to stabilize the hole, cool the drill bit, and control downhole pressure. A few hundred feet above the target shale, the drilling assembly comes to a stop. The entire string is retracted to the surface to adjust the drilling assembly and install a special drilling tool. This tool allows Chesapeake to gradually turn the drill bit until a horizontal plane is reached. The remainder of the well is drilled in this horizontal plane while in contact with the gas-producing shale. Drilling continues horizontally through the shale at lengths greater than 4,000 feet from the point where it entered the formation. Once drilling is completed, the equipment is retracted to the surface. Then, a smaller diameter casing, called production casing, is installed throughout the total length of the well. The production casing is cemented and secured in place by pumping cement down through the end of the casing. Depending on regional geologic conditions, the cement is pumped around the outside casing wall to approximately 2,500 feet above the producing shale formation or to the surface. The cement creates a seal to ensure that formation fluids can only be produced via the production casing. After each layer of casing is installed, the well is pressure tested to ensure its integrity for continued drilling. A cross-section of the well below surface reveals several protective layers: cement, conductor casing, cement, surface casing, drilling mud, production casing, and then production tubing, through which the produced gas and water will flow. 7 layers of protection. Horizontal drilling offers many advantages when compared to vertical drilling. Since horizontal wells contact more of the gas-producing shale, fewer wells are needed to optimally develop a gas field. Multiple wells can be drilled from the same pad sites. For example, development of a 1,280-acre tract of land using conventional vertical drilling techniques could require as many as 32 vertical wells, with each having its own pad site. However, one multi-well pad site with horizontal wells can effectively recover the same natural gas reserves from the 1,280-acre tract of land while reducing the overall surface disturbance by 90%.
Fracking is a technique that involves pumping water and sand at high pressure into shale formations. After drilling has been completed in a prospective location, the shale formation is perforated or punctured to prime it for the fracturing process. The area is then subjected to water and sand at high pressure to fracture the shale. Once fractured, sand is used to hold the small cracks and fissures open, releasing natural gas and allowing it to move up the wellbore to the surface. With this new technology, a land rush soon followed by gas producers to obtain the best locations in potential gas shale plays across the nation. More discoveries are made every year, and new industry estimates now state that the U.S. has a 100-year supply of natural gas. Today, natural gas is used all over the world as a versatile form of clean burning energy. Common uses include heating homes and powering hot water heaters, dryers, and stovetops. But its ability to adapt to so many other needed areas have made it an ideal energy for making plastics, powering electric turbines, and commercial chillers that cool office buildings. When used as an automotive fuel, compressed natural gas, or CNG, is a clean fuel that can power buses, trucks, and compact cars. Natural gas has proven to be a clean, affordable, abundant alternative to gasoline and coal. 99% of the natural gas used in the U.S. is produced at home in our own nation. With a variety of uses and new technology, natural gas is proving it's the energy of the future.